Good morning and welcome back to Reading Wikis for You, where we read the wiki articles for you. And today we're going to be taking a look at the M1 Abrams, a main battle tank of the United States Army. Now, as always, while I'm reading, do me a favor, drop an article, or not an article, a topic, something that you're interested in learning a little bit more about in the comments. Honestly, it can be anything. It can be military vehicles. It can be football teams. It can be, Warhammer, Battletech. Obviously, if you've been following the channel for a while, I cover all sorts of topics, so I'd love to hear what you want to know about next. But with that said, let's go ahead and get started. The M1 Abrams is a third-generation American main battle tank designed by Chrysler Defense, now General Dynamics Land Systems, and named for General Creighton Abrams. Conceived for modern armored ground warfare, it is one of the heaviest tanks in service at nearly 73.6 short tons. It introduced several modern technologies to the United States Armored Forces, including multi-fuel turbine engine, sophisticated Chobham composite armor, a computer fire control system, separate ammunition stowage in a blowout compartment, and NBC protection for crew safety. Initial models of the M1 were armed with a 105mm M68 gun, while later variants featured a license-produced Rheinmetall 120mm L44 designated the M256. The M1 Abrams was developed from the failed joint American-West German MBT-70 project that intended to replace the dated M60 tank. There are three main operational Abrams versions, the M1, M1A, and M1A2, with each new iteration seeing improvements in armament, protection, and electronics. The Abrams was to be replaced in the U.S. Army service by the XM-1202 mounted combat system, but following the project's cancellation, the Army opted to continue maintaining and operating the M1 series for the foreseeable future by upgrading optics, armor, and firepower. The M1 Abrams entered service in 1980 and serves as the main battle tank of the United States Army and formerly of the United States Marine Corps, until the decommissioning of all USMC tank battalions in 2021. The export modification is used by the armed forces of Egypt, Kuwait, Saudi Arabia, Australia, Poland, and Iraq. The Abrams was first used in combat by the U.S. in the Gulf War. It was later deployed by the U.S. in the war in Afghanistan and the Iraq War, as well as by Iraq in the war against the Islamic State, Saudi Arabia in the Yemeni Civil War, and Ukraine during the Russian invasion of Ukraine. History. Previous developments. In 1963, the U.S. Army and the West German Bundeswehr program began collaborating on the main battle tank design that both nations would use, improving interoperability between the two NATO partners. The MBT-70, or Kampfpanzer 70 as it was known in Germany, incorporated many new unconventional technologies. Conventional tanks at the time had a crew of 4 with a driver located in the hull. In the MBT-70, the loader crew member would be replaced by a mechanical autoloader and the driver would be located inside the NBC-protected turret with the other 2 crew members. Like the M60A2 main battle tank and M551 Sheridan light tank then under development, the MBT-70 was armed with a 152mm gun launcher that, in addition to firing conventional ammunition, would also fire the Shillelagh missile. A hydropneumatic suspension provided improved cross-country ride quality and also allowed the entire tank to be raised or lowered by the driver. The United States team was led by General Motors, while the German team consisted of a consortium of firms. The collaboration between the two teams was rocky from the start, with many cultural differences and disagreements about the design hampering progress. While the design was highly capable, its weight and budget both continued to grow. By 1969, the unit cost was many times the original estimate, approaching $1 million per tank. Due to increasing costs, delays, and overall uncertainty as to the soundness of the tank design, the United States and Germany ended their MBT-70 partnership in 1970. The U.S. Army began work on an austere version of the MBT-70 named the XM-803. Systems were simplified or eliminated altogether, and the unreliable autoloader was improved. These changes were ultimately insufficient to allay concerns about the tank's cost. Congress canceled the XM-803 in December 1971, but permitted the Army to reallocate remaining funds to develop a new main battle tank. Starting over. The Army began the XM-815 project in January 1972. The main battle tank task force was established under Major General William Desabry with the technical support of Tank Automotive and Armaments Command. In spring 1972, Desabry was briefed by the British on their own newly developed Burlington armor from the British Army's labs. The armor performed exceptionally against shaped charges such as heat rounds. In September, Desabry convinced the Army to incorporate the new armor to take full advantage of Burlington, also known as Chobham. The new tank would have to have armor around 2 feet thick. General Creighton Abrams set the weight of the new tank at 53 tons. The original goal of keeping weight under 45 tons was abandoned. At the time, the Pentagon's procurement system was beset with problems being caused by the desire to have the best possible design. This often resulted in programs being canceled due to cost overruns, leaving the forces with outdated systems, as was the case with the MBT-70. There was a strong movement within the Army to get a new design within budget to prevent the MBT-70 experience from repeating itself. For the new design, the Army set the design to unit cost at no more than $507,790. The Pentagon's approach to control of research and development was modified with the XM1. Previous acquisition strategy called for a significant amount of the design work to be done by the government. Under the new framework, contractors would competitively bid their own designs rather than compete solely for the right to manufacture the end product. In January 1973, the U.S. Army issued the XM1 request for proposals. The new tank had to defeat any hit from a Soviet gun within 800 meters and 30 degrees to either side. The tank would be armed with a 105mm M68 gun, a licensed version of the Royal Ordnance L7, and a 20mm version of the M242 Bushmaster. The Army later deleted the latter from the design. In May 1973, Chrysler Defense and General Motors submitted proposals. Both were armed with the 105mm M68 gun, the licensed L7, and the 20mm Bushmaster. Chrysler chose a 1,500 horsepower Lycoming AGT 1500 gas turbine engine. GM's model was powered by a 1,500 horsepower diesel engine similar to that used on the American MBT-70 and XM803. Prototypes. Prototypes were delivered in 1976 by Chrysler and GM, armed with the M68E1 105mm gun. They entered head-to-head testing at Aberdeen Proving Ground. The testing showed that the GM design was generally superior to Chrysler's, offering better armor protection and better fire control and turret stabilization systems. During testing, the power packs of both designs proved to have issues. The Chrysler gas turbine engine had extensive heat recovery system in an attempt to improve its fuel efficiency to something similar to a traditional internal combustion engine. This goal was not achieved. The engine consumed much more fuel than expected, burning 890 liters per 100 kilometers. The GM design used a new variable compression diesel design. By spring 1976, the decision to choose the GM design was largely complete. In addition to offering better overall performance, there were concerns about Chrysler's engine, both from a reliability and fuel consumption standpoint. The GM program was also slightly cheaper overall at $208 million compared to $221 million for Chrysler. In July 1976, the Army prepared to inform Congress of the decision to move ahead with the GM design. All that was required was the final sign-off by the U.S. Secretary of Defense, Donald Rumsfeld. Back to the drawing board. In July 1976, Defense Secretary Rumsfeld announced a 4-month delay in the award of the XM1 contract. Over the Army's objections, Rumsfeld had heeded his deputy's call to make the turbine engine a requirement of the XM1. Within days of the announced delay, GM was asked to present a new design with a turbine engine. According to Assistant Secretary for Research and Development Ed Miller, it became increasingly clear that the only solution which would be acceptable to Clements and Curie was the turbine. It was a political decision that was reached, and for all intents and purposes, that decision gave the award to Chrysler since they were the only contractor with a gas turbine, unquote. In the meantime, in September 1976, 3 West German Leopard 2AV prototypes were belatedly sent to Aberdeen for comparison testing. Germany had signed a somewhat vague Memorandum of Understanding in 1974, committing both parties towards commonality in tank parts. Germany had assumed that its tank would be evaluated against the GM and Chrysler's prototypes and that the best tank would be chosen for production. This misunderstanding arose from the fact that in public statements both countries had overrepresented the Memorandum of Understanding as an agreement that Germany and the U.S. would select a common MBT. In reality, the U.S. Army was unwilling to choose a foreign tank unless it was obviously superior in design and cost. In any case, in evaluations, the Leopard 2AV was found to meet U.S. requirements but was thought to cost more. The U.S. Army announced in January 1977 that Germany had withdrawn the tank from consideration. Chrysler is chosen. Having narrowly averted losing the contract, Chrysler set about improving the design. Expensive components were replaced with less expensive ones. Chrysler's team also negotiated lower costs from their subcontractors. Chrysler also submitted a version with a Teledyne AVCR 1360 diesel engine. Chrysler's new bid came to $196 million, down from $221 million in the original proposal. GM's proposal replaced the diesel engine with an AGT 1500 turbine and integrated a turret capable of mounting either the 105mm or 120mm gun. Cost growth pushed the tank bid $232 million from $208 million. Although the GM team had successfully integrated the turbine, Baer was more impressed by the cost savings introduced by the Chrysler team's redesign. On 12 November 1976, the Defense Department awarded the $4.9 billion development contract to Chrysler. The turbine engine and cost do not appear to be the only reason for the selection of Chrysler. Chrysler was the only company that appeared to be seriously interested in tank development. The M60 had been lucrative for the company. In contrast, GM made only about 1% of its income from military sales, compared to 5% for Chrysler, and only submitted their bid after a special plea from the Pentagon. 11 XM1 pre-production models were manufactured between February and July 1978 at Detroit Arsenal Tank Plant. Quality problems with the engine quickly became apparent in testing. The first pre-production units that arrived at Aberdeen Proving Ground in March 1978 had serious problems. The tank accumulated mud and dirt under the hull, which led to thrown tracks. Chrysler installed a scraper to prevent the buildup of dirt, but this did not solve the issue entirely. It was determined months later that a gauge used to tension tracks was miscalibrated. This caused the tracks to be fitted too loosely. Another problem was the ingestion of debris by the engine. The problem was determined to be caused by poorly fitting air filters. The 60 Minutes news program reported in 1980 on a faulty air filter induction system, but an Army spokesperson said that the problem was resolved prior to the airing of the episode. At Fort Bliss, several tanks experienced transmission issues. It was determined that the tankers at Fort Bliss had discovered that they could throw the vehicle directly from acceleration into reverse, a tactically advantageous maneuver called the bow tie. Chrysler resolved this by installing a device that prevented this. The problems found during testing were easily surmounted. Critics of the M1 program emerged in the early 1980s, particularly the newly formed Project on Military Procurement, or PMP. PMP took issue with the tank's vulnerability, high price, reliance on flammable hydraulics, and high fuel consumption. Responding to some of the alleged issues with the tank in King of the Killing Zone, journalist Orr Kelly wrote that, quote, "The truth is close to the opposite, and that the program ranks as one of the Army's best managed, producing a tank in a remarkably short time while avoiding gold plating and utilizing effective competition," unquote. American tank historian Stephen J. Zaloga characterized American press criticism of the M1 during this time as ill-founded, and that the issues uncovered by the tank trials were not particularly serious. PMP's criticism failed to generate any serious opposition to the program, which maintained strong support from Congress and the Pentagon. Production starts. Low initial rate production of the vehicle was approved in May 1979. In February 1982, General Dynamics Land Systems Division purchased Chrysler Defense after Chrysler built over 1,000 M1s. A total of 3,273 M1 Abrams tanks were produced during 1979 to 1985 and first entered U.S. Army service in 1980. Production at the government-owned GDLS-operated Lima Army Tank Plant in Lima, Ohio, was joined by vehicles built at the Detroit Arsenal Tank Plant in Warren, Michigan from 1982 to 1981. The U.S. Army Laboratory Command, under the supervision of the United States Army Research Laboratory, was also heavily involved with designing the tank with M1A1 armor-resistant shells, M829A2 armor-penetrating rounds, and improved weapon range. The M1 was armed with the license-built M68A1 version of the 105mm Royal Ordnance L7 gun. The tank featured the first-of-its-kind chobham armor. The M1 Abrams was the first to use this advanced armor. It consisted of an arrangement of metal and ceramic plates. An improved model called the IPM-1 was produced briefly in 1984 and contained upgrades to armor and other small improvements. 120mm gun M1A1. A number of considerations had led to the service and its contractors to favor the Army standard M68 105mm gun over Germany's 120mm Rheinmetall RH-120 smoothbore gun for the XM1. To begin with, the 105mm gun was the smallest, lightest, and least costly gun adequate for the job. Indeed, new kinetic energy ammunition for the weapon, then under development by the Army, promised to extend the gun's usefulness well into the future. And because the Army's other tanks, the M60 and the upgraded M48, as well as the tanks of virtually every other NATO nation, used the 105mm gun, mounting that gun on the XM1 promised to increase standardization within the alliance. Moreover, the continuing development of the new ammunition for the XM1 automatically upgraded every other gun in NATO. For all of these reasons, the XM1's development proceeded on the assumption that the 105mm gun would probably be the eventual main armament. The tripartite British, American, German gun trials of 1975 produced a general agreement in the U.S. Defense Department that at some future point, a 120mm gun of some design would be added to the XM1. Apparently anticipating this, Chrysler and GM had both made changes to their tanks during development to make them compatible with a variety of main guns. In January 1978, the Secretary of the Army announced that the Rheinmetall 120mm gun would be mounted on future production versions of the XM1. This decision established the requirement for a separate program for the XM1E1 so that the XM1 program could continue unimpeded. About 5,000 M1A1 Abrams tanks were produced from 1986 to 1992 and featured the M256 120mm smoothbore cannon, improved armor, consisting of depleted uranium and other classified materials, and a CBRN protection system. Production of M1A1 tanks totaled some 9,000 tanks at a cost of approximately $4.3 million per unit. In 1990, a Project on Government Oversight report criticized the M1's high cost and low fuel efficiency in comparison with other tanks of similar power and effectiveness, such as the Leopard II. As the Abrams entered service, they operated alongside M60A3s within the United States military and with other NATO tanks in various Cold War exercises, which usually took place in Western Europe, especially West Germany. These exercises were aimed at countering Soviet forces. Adaptations before the Gulf War gave the vehicle better firepower and nuclear, biological, and chemical protection. Gulf War. The Abrams remained untested in combat until the Gulf War in 1991, during Operation Desert Storm. The first Abrams tanks to arrive in Saudi Arabia in August 1990 and the build-up to the war were the M1 and IPM-1 tanks with 105mm guns. All but 2 battalions of 105mm gun Abrams tanks were replaced by M1A1 tanks prior to the American invasion in January 1991. The U.S. Army deployed a total of 1,956 M1A1s to Saudi Arabia to participate in the liberation of Kuwait. The U.S. Marine Corps deployed 353 tanks, of which 277 were M60s and 76 were M1A1. The M1A1 common variant included adaptations for deep weighting and improvements to increase commonality with the Army's Abrams. The 2nd Tank Battalion was equipped with M1A1HA Abrams borrowed from the Army. The M1A1 was superior to Iraq's Soviet-designed T-54 and T-55 and T-62 tanks, as well as T-72 versions imported from the Soviet Union and Poland. Polish officials stated that no license-produced T-72, nicknamed Lion of Babylon tanks, were finished before the destruction of the Iraqi Taji tank plant in 1991. Iraq's T-72s, like most Soviet export designs, lacked night vision systems and then modern rangefinders, though they did have some night fighting tanks with older active infrared systems or floodlights. Very few M1 tanks were hit by enemy fire, and none were destroyed as a direct result of enemy fire, none of which resulted in any fatalities. 3 Abrams were left behind the enemy lines after a swift attack on Talil airfield south of Nasirah on February 27th. One of them was hit by enemy fire, while the other 2 became embedded in mud. The tanks were destroyed by U.S. forces to prevent any trophy claim by the Iraqi army. A total of 23 M1A1s were damaged or destroyed during the war. Of the 9 Abrams tanks destroyed, 7 were destroyed by friendly fire, and 2 intentionally destroyed to prevent capture by the Iraqi army. No M1s were lost to enemy tank fire. Some others took minor combat damage with little effect on their operational readiness. The M1A1 could kill other tanks at ranges in excess of 8,200 feet. This range was crucial in combat against previous generation tanks of Soviet design in Desert Storm, as the effective range of the main gun in the Iraqi tanks was less than 6,600 feet. This meant Abrams tanks could hit Iraqi tanks before the enemy got in range, a decisive advantage in this kind of combat. In friendly fire incidents, the front armor and 4 side turret armor survived direct APF SDS hits from other M1A1s. This was not the case for the side armor of the hull and the rear armor of the turret, as both areas were penetrated on at least 2 occasions by unintentional strikes by depleted uranium ammunition during the Battle of Norfolk. Waco Siege. During the Waco Siege in 1993, two M1 Abrams tanks were borrowed from the military and deployed by the FBI against the Branch Davidians. Upgrades. The M1A2 was a further improvement of the M1A1 with a commander's independent thermal viewer, weapon station, position navigation equipment, and a full set of controls and displays linked by a digital data bus. These upgrades also provided the M1A2 with an improved fire control system. The M1A2 system enhancement package added digital maps, Force 21 Battle Command Brigade, and below, Linux communication system capabilities for commanders, and an improved cooling system to compensate for heat generated by the additional computer systems. The M1A2 SEP also serves as the basis for the M104 Wolverine Heavy Assault Bridge. The M1A2 SEP V2 added common remotely operated vehicle station, support, color displays, better interfaces, a new operating system, better front and side armor, and an upgraded transmission for better durability. Further upgrades include depleted uranium armor for all variants, a system overhaul that returns all A1s to like new condition, a digital enhancement package for the A1, and a commonality program to standardize parts between the U.S. Army and the Marine Corps. Improvements to survivability, lethality, and protection have been sought since 2014. Iraq War. Further combat was seen during 2003 when the U.S. forces invaded Iraq and deposed Iraqi President Saddam Hussein in the Iraq War's Operation Iraqi Freedom. One achievement of the M1A1s was the destruction of 7 T-72s in a point-blank skirmish near Mahmoudiya, about 18 miles south of Baghdad, with no U.S. losses. This was in the face of inadequately trained Iraqi tank crews, most of whom had not fired live ammunition in the previous year due to the sanctions then in operation and made no hits at point-blank range. Following lessons learned in Desert Storm, the Abrams and many other U.S. combat vehicles used in the conflict were fitted with combat identification panels to reduce friendly fire incidents. Several Abrams tanks that were irrecoverable due to the loss of mobility or other circumstances were destroyed by friendly forces, usually by other Abrams tanks to prevent their capture. Some Abrams tanks were disabled by Iraqi infantrymen in ambushes during the invasion. Some troops employed short-range anti-tank rockets and fired at the tracks, rear, and top. Other tanks were put out of action by engine fires when flammable fuel stored externally in turret racks was hit by small arms fire and spilled into the engine compartment. By March 2005, approximately 80 Abrams tanks had been forced out of action by enemy attacks. 63 were shipped back to the U.S. for repairs, while 17 were damaged beyond repair, with 3 of them at the beginning of 2003. Vulnerabilities exposed during urban combat in the Iraq War were addressed with the Tank Urban Survival Kit modifications, including armor upgrades and a gun shield issued to some M1 Abrams tanks. In addition to protection in the rear and side of the tank and improved fighting ability and survival ability in urban environments. By December 2006, more than 530 Abrams tanks had been shipped back to the U.S. for repairs. In May 2008, it was reported that a U.S. M1 tank had also been damaged in Iraq by insurgent fire of a Soviet-made RPG-29 Vampire, which uses a tandem charge heat warhead to penetrate explosive reactive armor, as well as composite armor behind it. The U.S. considered the RPG-29 a high threat to armor and refused to allow the newly formed Iraqi army to buy it, fearing that it would fall into the insurgents' hands. Iraqi Army Service. Between 2010 and 2012, the U.S. supplied 140 refurbished M1A1 Abrams tanks to Iraq. In mid-2014, they saw action when the Islamic State of Iraq and the Levant launched the June 2014 Northern Iraq Offensive. During 3 months, about one-third of the Iraqi Army's M1 tanks had been damaged or destroyed by ISIL, and some were captured by opposing forces. By December 2014, the Iraqi Army only had about 40 operational Abrams left. That month, the U.S. Department of State approved a sale of another 175 Abrams to Iraq. Iranian-backed Iraqi Shiite Kataib Hezbollah were reported to operate M1 Abrams and released publicity showing the tanks being transported by trucks to take part in the Battle of Mosul. It is not known whether the tanks were captured from ISIL, seized from Iraq's military, or handed over. One Iraqi-operated Abrams has been nicknamed the Beast after it became the lone working tank when taking back the town of Hit in April of 2016, destroying enemy fighting positions and IED emplacements. In October 2017, Abrams were used by the Iraqi security forces and the Popular Mobilization Forces also called al-Hashd al-Shabi, and assaults against the Kurdistan Regional Government Peshmerga in the town of Altan Kupri, also called Purd. It was claimed by the Kurdish commanders that at least one Abrams was destroyed by the Peshmerga. War in Afghanistan. Canada and Denmark deployed Leopard 1 and 2 MBTs that were specially modified to operate in the relatively flat and arid conditions of southwestern Afghanistan. In late 2010, at the request of Regional Command Southwest, the U.S. Marine Corps deployed a small detachment of 14 M1 Abrams tanks from Delta Company, 1st Tank Battalion, 1st Marine Division, to southern Afghanistan in support of operations in Helmand and Kandahar provinces. 2015 Yemen Civil War. Saudi Abrams tanks saw service in the 2015 Yemeni Civil War, where M1A2s were used against Houthi rebels. In August 2016, the U.S. approved a deal to sell up to 153 more Abrams tanks to Saudi Arabia, including 20 battle damage replacements, suggesting that some Saudi Arabian Abrams had been destroyed or severely damaged in combat in Yemen. Russo-Ukrainian War. Russian invasion of Ukraine. In January 2023, U.S. President Joe Biden said that the United States would send 31 M1 Abrams tanks to Ukraine. The plan to transfer the tanks to Ukraine was approved as part of a larger aid package. Pentagon spokesperson Sabrina Singh specified that the tanks would be the M1A2 variant. However, because they were not available in excess in U.S. stocks, they would be purchased through Ukraine's Security Assistance Initiative and could take up to 2 years to manufacture and deliver. In March 2023, the Pentagon announced that in order to expedite delivery, modernized M1A1SA variants would be pulled from Army stocks and refurbished for delivery by the fall. This change would also ensure deliveries to U.S. allies of new M1A2s would not be disrupted. In September 2023, Ukraine began receiving these tanks, which were former U.S. Marine Corps tanks. The tanks supplied were also older, having entered service in 1986, but modernized to M1A1SA, or situational awareness standards. In February 2024, an M1A1 was reported as lost in Ukraine. The blowout panels on the ammo bins had been activated, indicating that the ammunition had cooked off. This M1A1 was destroyed by an FPV Piranha 10 quadcopter. In April 2024, Pentagon officials reported that Ukraine's Abrams had been withdrawn from frontline service. The Russian use of hunter-killer drones have made it too difficult to operate the tanks in the current battlefield, with muddy ground hindering maneuverability. A Ukrainian company has unveiled a new set of anti-drone steel screens, which weighs approximately 430 kilograms. Designed to protect the tank while not hindering its functions, the screens also use Soviet-era Contact 1 explosive reactive armor. The screens protect the turret's top, rear, and sides and other vulnerable sections. It leaves opening for smoke grenade launchers, the commander's hatch, and other parts of the tank. Some 7 sets of armor have been produced, according to the company, for the Ukrainian Abrams. One Abrams was captured by Russia and displayed as a war trophy in Moscow in May 2024. In October 2024, Australia announced that 49 recently retired M1A1 tanks would be transferred to Ukraine as the Australian Army started receiving its new M1A2 models. As of 5 November 2025, Oryxpionkop website stated that Ukraine had visually confirmed losses of 22, 10 destroyed, 1 damaged, 10 abandoned, and 1 captured, of the 31 USA-provided Abrams tanks. On 19 July 2025, Australia announced that Ukraine had received the majority of the M1 Abrams tanks, which according to the Sydney Morning Herald was around 40 tanks, with the remaining tanks to be delivered in the coming months. On 19 December 2025, ABC News reported that the final 12 M1A1 tanks donated by Australia had been transferred to Ukraine. Production. Serial production of the M1 Abrams for the U.S. Army ended in 1995, though production for exports continued until 2000. The U.S. Army sought to suspend operations at Joint Systems Manufacturing Center, formerly Lima Army Tank Plant, from 2013 to 2016 to save over $1 billion. These plans were averted by Congress, which continued allocating money towards upgrading tanks. Specifically, GDLS estimated that closing the plant would cost $380 million and restarting production would cost $1.3 billion. In late 2016, tank production and refurbishment had fallen to a rate of 1 per month with fewer than 100 workers on site. In 2017, President Donald Trump ordered military production to increase, including Abrams production and employment. In 2018, it was reported that the Army had ordered 135 tanks rebuilt to new standards, with employment at over 500 workers and expected to rise to 1,000. U.S. Marine Corps divestments. The Marine Corps began divesting itself of the Abrams in 2020 as part of a force restructuring plan intended to improve the Marine Corps' ability to contend with near-peer adversaries in the Pacific region, specifically to deter a possible Chinese invasion of Taiwan. Under the restructuring, the Marine Corps would shift its strategy towards distributed operations, an area planners felt the Abrams was unsuited for. In 2020, the final M1 A1 left Camp Lejeune, marking the end of the use of heavy armor in the Marine Corps. Marines previously serving within armor roles were given the opportunity to transfer to the Army to continue serving in armor roles, change their occupational specialty within the Marines, or retire from the Corps early. Future plans. During the 1980s and 1990s, the Block III main battle tank from the Armored Systems Modernization Program was expected to succeed the M1 Abrams family in the 1990s. The design had an unmanned turret with a 140mm main gun, as well as improved protection. The end of the Cold War hostilities caused the end of the program. The tracked M8 armored gun system was conceived as a possible supplement for the Abrams in the U.S. service for low-intensity conflict in the early 1990s. Prototypes were made, but the program was canceled. The 8-wheeled M1128 mobile gun system was designed to supplement the Abrams in U.S. service for low-intensity conflicts. It has been introduced into service and serves with the Stryker brigades. The Future Combat Systems XM1202 mounted combat system was to replace the Abrams in U.S. Army service and was in development when funding for the program was canceled in 2010. Engineering Change Proposal 1 is a two-part upgrade process. ECP-1A adds space, weight, and power improvements and active protection against improvised explosive devices. 9 ECP-1A prototypes have been produced as of October 2014. ECP-1B, which would begin development in 2015, may include sensor upgrades and converging several tank round capabilities into a multi-purpose round. As of 2021, the Army anticipated that the remaining M1A2 to beyond 2050. As of 2021, the Army is to begin divesting its M1A1 SA variants in the fiscal year 2025. As of March 2023, the U.S. Army has had a stated goal of procuring 2,204 M1A2 SEPV3 tanks, with funds already having been committed to produce 2,093 of this variant. This will make the M1A2 SEPV3 the standard issue tank for the U.S. Army and the U.S. Army National Guard. As of 2021, the U.S. Army was evaluating a replacement for the M1 Abrams as part of the Next Generation Combat Vehicle program, nationally known as the Decisive Lethality platform. In September 2023, the U.S. Army announced that it had canceled the planned M1A2 SEPV4 variant and would instead redirect resources into a new variant of the Abrams tank, the M1E3. In June 2025, it was reported that the U.S. Army had planned upgrades to Abrams tanks to make them more survivable in the battlefield after lessons from the Ukraine. Design. Countermeasures. Camouflage. Some XM1 FSED pilot vehicles and XM1 LRIP tanks were painted with the MERDC 4-color paint scheme, which is named after the center that developed it, the Mobility Equipment Research and Development Center. Factory-applied forest green paint gave way to Europe 1, a 3-color pattern, in 1983 at the same time as chemical agent-resistant coating was adopted. Europe 1 consisted of green 383, brown 383, and black colors. The U.S. Army Abrams deployed to the Iraq War were painted Kark Tan 686A. Due to the increasing significance of American operations in Europe, the U.S. Army transitioned most of its vehicles to CARC green 383 starting in around 2017. M1A1s come from the factory with the NATO 3-color camouflage, black, medium green, dark brown CARC paint jobs. Today, M1A1s are given the NATO 3-color paint job during rebuilds. M1s and M1A1s deployed to Operation Desert Storm were hastily painted Desert Tan. Some, but not all, of these tanks were repainted to their authorized paint scheme. M1A2s built for Middle Eastern countries were painted in Desert Tan. Replacement parts, such as road wheels, armor skirt panels, drive sprockets, etc., are painted olive green, which can sometimes lead to vehicles with a patchwork of green and desert tan parts. Australian M1A1s are camouflaged in OSCAM, a scheme that consists of black, olive drab, and brown. Concealment. The turret is fitted with two 6-barreled M250 smoke grenade launchers, with one on each side. When deployed, the grenades airburst, creating a thick smoke that blocks both visual and thermal imaging. The engine is also equipped with a vehicle engine exhaust smoke system that is triggered by the driver. When activated, fuel is sprayed into the hot turbine exhaust, creating thick smoke. This system was discontinued by the U.S. Army after it switched to JP-8 jet fuel in the 1990s due to the risk of fire. Armor. In addition to conventional rolled homogeneous armor, the Abrams uses a secret British-developed Chobham composite armor. The M1 Abrams composite armor is most substantial at the front of the hull, where it is 2 feet at its thickest. The front of the hull is armored with composites. The Abrams turret features composite armor across both the front and sides. The armor is much thicker on the Abrams than on previous tanks. It is not a reflection of any weakness of Chobham armor. Pound for pound, Chobham is better at stopping shaped charges and kinetic projectiles. Rather, unlike RHA, Chobham is optimized against shaped charge projectiles. Effective shaped charges, particularly anti-tank guided missiles, were a relatively new battlefield innovation. Lacking a breakthrough advance in novel armor material to negate shaped charges, previous tank designers had simply not found it practical to add the amount of RHA required to defeat shaped charges. While the exact composition of the Abrams composite armor remains a state secret, a generalization about how it works can be gleaned from what has been publicly said about it. It consists of ceramic blocks set in resin between layers of conventional armor. The ceramic acts as a non-explosive reactive armor, disrupting shaped charges. The NERA plates shatter on impact with the projectile, disrupting the penetrating jets of shaped charges, or in the case of kinetic rounds, eroding the projectile. For the M1 Abrams base model, military historian Stephen Zaloga estimates the frontal armor at 350mm versus APF SDS and 700mm versus Heat warhead in the book, M1 Abrams main battle tank 1982 to 1992. In M1 Abrams versus T-72 Ural 2009, he uses Soviet estimates of 470mm versus APF SDS and 650mm versus Heat for the base model Abrams. He also gives the Soviet estimates for the M1A1 600mm versus APF SDS and 700mm versus Heat. Armor protection against kinetic energy rounds was improved by implementing a new special armor incorporating depleted uranium. This was introduced into the M1A1 production starting October 1988, but at the expense of adding considerable weight to the tank, as depleted uranium is 1.7 times denser than lead. The depleted uranium is applied to the backing plate of the turret armor arrays. The first M1A1 tanks to receive this upgrade were tanks stationed in Germany. U.S.-based tank battalions participating in Operation Desert Storm received an emergency program to upgrade their tanks with depleted uranium armor immediately before the onset of the campaign. M1A2 tanks uniformly incorporate depleted uranium armor, and all M1A1 tanks in active service have been upgraded to this standard as well. This variant was designed as the M1A1HA, or heavy armor. The M1A1 AIM, M1A2 SEP, and all subsequent Abrams models feature depleted uranium. Each Abrams variant after the M1A1 have been equipped with depleted uranium armor of different generations. The M1A1HA uses first-generation armor, while the M1A2 and M1A1HC use second-generation depleted uranium. The M1A2 SEP variants have been equipped with third-generation depleted uranium armor combined with a graphite coating. For the M1A1HA, Zaloga gives the frontal armor estimate of 600mm versus APF SDS and 1300mm versus Heat in M1 Abrams main battle tank 1982 to 1992, nearly double the original protection of the Abrams. In M1 Abrams versus T-72 Ural, he uses different estimates of 600mm versus APF SDS and 700mm versus Heat for the front hull, and 800mm versus APF SDS and 1300mm versus Heat for the front of the turret. The protection of the M1A2 SEP is a frontal turret armor estimate of 940 to 960 millimeters versus APF SDS and 1,320 to 1,620 millimeters versus Heat. Glacis estimate of 560 to 590 millimeters versus APF SDS and 510 to 1,050 millimeters versus Heat, and lower front hull estimate of 580 to 650 millimeter versus APF SDS and 800 to 970 millimeters versus Heat. The M1A2 SEPV3 increased the LOS thickness of the turret and hull front armor. Total armor protection from this increase is not known. In 1998, a program was begun to incorporate improved hull, turret, and sight armor into the M1A2. This was intended to offer better protection against rocket-propelled grenades that were more modern than the baseline RPG-7. These kits were installed on about 325 older M1A2 tanks in 2001 to 2009 and were also included in upgraded tanks. The Abrams may also be fitted with explosive reactive armor over the track skirts if needed, and slat armor over the rear of the tank and rear fuel cells to protect against ATGMs. The 105mm M1 Abrams does not use spall liners, though 3 105mm rounds on the turret basket floor are covered with spall protection covers on the M1 tank variant. Damage control. The tank has a halon firefighting system to automatically extinguish fires in the crew compartment. The engine compartment has a firefighting system that is engaged by pulling a T-handle located on the left side of the hull. The halon gas can be dangerous to the crew. However, the toxicity of halon 1301 gas at 7% concentration is much lower than the combustion products produced by fire in the crew compartment, and CO2 dump would be lethal to the crew. The crew compartment also contains small handheld fire extinguishers. Fuel and ammunition are stored in armored compartments with blowout panels intended to protect the crew from the risk of the tank's own ammunition cooking off or exploding if the tank is damaged. The main gun's ammunition is stored in the rear section of the turret, with blast doors that open under power by sliding sideways only to remove a round for firing, then automatically close. Doctrine mandates that the ammunition door must be closed before arming the main gun. NBC protection. Starting with the M1A1 variant, nuclear, biological, chemical protection was provided by a turret overpressure system. Previously, the Abrams crew had been required to don NBC suits in case of an NBC attack. NBC masks are still retained as a backup, and crews often train while wearing them to remain proficient and combat effective in such a scenario. Tank Urban Survival Kit. The Tank Urban Survival Kit, or TUSK, is a series of improvements to the M1 Abrams intended to improve fighting ability in urban environments. Historically, urban and other close battlefields have been poor places for tanks to fight. A tank's front armor is much stronger than that on the sides, top, or rear. In an urban environment, attacks can come from any direction, and attackers can get close enough to reliably hit weak points in the tank's armor or gain sufficient elevation to hit the top armor. Armor upgrades include reactive armor on the sides of the tank and slat armor on the rear to protect against rocket-propelled grenades and other shape-charged warheads. Abrams Reactive Armor Tile 1 consists of 32 XM19 reactive armor boxes added to the side of the tank. ARAT2 consists of rounded XM32 reactive armor tiles mounted over top of the XM19 tiles. A transparent armor gun shield and a thermal sight system are added to the loader's top-mounted M240B 7.62mm machine gun. And a Kongsberg Gruppen remote weapon turret carrying a 12.7mm caliber machine gun is in place of the tank commander's original 50 caliber machine gun mount, wherein the commander had to expose himself to fire the weapon manually. An exterior telephone allows supporting infantry to communicate with the tank commander. In August 2006, General Dynamics Land Systems received a U.S. Army order for 505 tank urban survivability kits for Abrams main battle tanks supporting operations in Iraq under a U.S. $45 million contract. Deliveries were expected to be completed by April 2009. Under a separate order, the U.S. Army awarded General Dynamics Armament and Technical Products $30 million to produce reactive armor kits to equip M1A2s. Tiles will be produced at the company's reactive armor facility in Stone County Operations, McHenry, Mississippi. In December 2006, the U.S. Army added counter-improvised explosive device enhancements to the M1A1 and M1A2 TUSK, awarding GDLS an $11.3 million contract, part of the $59 million package mentioned above. In December, GDLS also received an order amounting to around 40% of a U.S. $48 million order for loaders' thermal weapon sights being part of the TUSK system improvements for the M1A1 and M1A2 Abrams tanks. Active Protection System. In addition to the armor, some USMC Abrams tanks were equipped with a soft kill active protection system, the AN-VLQ-6 missile countermeasure device, that can impede the function of guidance systems of some semi-active control line of sight, wire, and radio-guided anti-tank missiles, such as the Russian 9K-114 Sturm and infrared homing missiles. These were not ready in time for the Gulf War. The MCD works by emitting a massive condensed infrared signal to confuse the infrared homing seeker of an anti-tank guided missile. However, the drawback to the system is that the anti-tank guided missile is not destroyed. It is merely directed away from its intended target, leaving the missile to detonate elsewhere. During the Iraq War, the U.S. Marine Corps equipped its M1A1s with an AN-VLQ-8A electro-optical jammers. In 2016, the U.S. Army and Marine Corps began testing the Israeli Trophy Active Protection System to protect their Abrams tanks from modern RPG and ATGM threats by either jamming or firing small rounds to deflect incoming projectiles. The Army planned to field a brigade of over 80 tanks equipped with Trophy to Europe in 2020. It is planned for up to 261 Abrams to be upgraded with the system, enough for 4 brigades. In June 2018, the Army awarded Leonardo DRS, U.S. partner to Trophy's designer Rafael, a $193 million contract to deliver the system in support of M1 Abrams' immediate operational requirements. The U.S. Army M1A2 SEPV-2 Abrams tanks deployed to Germany in July 2020 fitted with Trophy systems. Deliveries to equip 4 tank brigades were completed in January 2021. Armament. Primary. M68A1 rifled gun. The main armament of the original model M1 and IPM1 was the M68A1 105mm rifled tank gun, firing a variety of armor-piercing, fin-stabilized, discarding sabot, high-explosive anti-tank, high-explosive, white phosphorus rounds, and an anti-personnel round. The gun used a license-made tube of the British Royal Ordnance L7 gun together with the vertical sliding breech block and other parts of the US T254E2 prototype gun. However, a longer-ranged weapon was always envisaged with lethality beyond 1.9 miles to combat newer armor technologies. To attain that lethality, the projectile diameter needed to be increased. The tank was able to carry 55 105mm rounds, with 44 stored in the turret blowout compartment and the rest in hull stowage. Being non-combustible, the empty cartridge cases of the M1 variant accumulated on the turret floor after firing. After allowing some time to cool, they were ejected out of the hatch by the loader. M256 smoothbore gun. The main armament of the M1A1 and M1A2 is the M256 120mm smoothbore gun. Designed by Rheinmetall AG of Germany, manufactured under license in the US by Watervliet Arsenal, New York. The M256 is an improved variant of the Rheinmetall 120mm L44 gun, carried on the German Leopard 2 on all variants up to the Leopard 2A5, the difference being in thickness and chamber pressure. Leopard 2A6 replaced the L44 barrel with a longer L55. Due to the increased caliber, only 40 or 42 rounds are able to be stored depending on if the tank is an A1 or A2 model. Elevation, -9 to +20 degrees. The M256 fires ammunition with combustible cartridge cases made out of nitrocellulose. The cartridges were safer against premature ignition and flarebacks than easier combustible cartridge rounds, but not entirely accident-proof. The M256 fires a variety of rounds. The primary APF-SDS round of the Abrams is the depleted uranium M829 round, of which 4 variants have been designed. M829A1, known as the Silver Bullet, saw widespread service in the Gulf War, where it proved itself against Iraqi armor such as the T-72. The M829A2 APF-SDS round was developed specifically as an immediate solution to address the improved protection of a Russian T-72, T-80U, or T-90 main battle tank equipped with Contact 5 explosive reactive armor. Later, the M829A3 round was introduced in 2002 to improve its effectiveness against next-generation ERA-equipped tanks. Development of the M829 series is continuing with the M829A4, currently entering production, featuring advanced technology such as a data link capability. The Abrams also fires heat warhead-shaped charge rounds such as the M830, the latest version of which incorporates a sophisticated multimode electronic sensing fuse and more fragmentation that allows it to be used effectively against armored vehicles, personnel, and low-flying aircraft. The Abrams uses a manual loader who also provides additional support for maintenance, observation post, listening post operations, and other tasks. The new M1028 120mm anti-personnel canister cartridge was brought into service early for use in the aftermath of the 2003 invasion of Iraq. It contains 1,098 3/8 of an inch tungsten balls that spread from the muzzle to produce a shotgun effect lethal out to 600 meters. The tungsten balls can be used to clear enemy dismounts, break up hasty ambush sites in urban areas, clear defiles, stop infantry attacks and counterattacks, and support friendly infantry assaults by providing covering fire. The canister round is also a highly effective breaching round and can level cinder block walls and knock man-sized holes in reinforced concrete walls for infantry raids at distances of up to 75 meters. Also in use is the M908 obstacle reduction round. It is designed to destroy obstacles and barriers. The round is a modified M830A1 with the front fuse replaced by a steel nose to penetrate into the obstacle before detonation. The U.S. Army Research Laboratory conducted a thermal analysis of the M256 from 2002 to 2003 to evaluate the potential of using a hybrid barrel system that would allow for multiple weapon systems such as the XM1111 mid-range munition, airburst rounds, or XM1147. The test concluded that mesh density impacts accuracy of the M256 and specific densities would be needed for each weapon system. In 2013, the Army was developing a new round to replace the M830-830A1, the M1028, and M908. Called the M1147 Advanced Multi-Purpose round, it will have point detonation, delay, and airburst modes through an ammunition data link and a multi-mode programmable fuse in a single munition. Having one round that does the job of 4 would simplify logistics and be able to be used on a variety of targets. The AMP is to be effective against bunkers, infantry, light armor, and obstacles out to 500 meters, and will be able to breach reinforced concrete walls and defeat ATGM teams from 500 to 2,000 meters. Orbital ATK was awarded a contract to begin the first phase of development for the AMP XM1147 high-explosive multi-purpose with tracer cartridge on October 2015. As of 2024, the round is undergoing its final testing stages, with a full-rate production decision scheduled for the end of the year. In addition to these, the XM1111 was also in development. The XM1111 was a guided munition using a dual-mode seeker that combined imaging, infrared, and semi-active laser guidance. The MRM-CE was selected over the competing MRM-KE, which used a rocket-assisted kinetic energy penetrator. The CE variant was chosen due to its better effects against secondary targets, providing a more versatile weapon. The Army hoped to achieve IOC with the XM1111 by 2013. However, the mid-range munition was canceled in 2010 along with future combat systems. Secondary. The Abrams has 3 machine guns with an optional 4th. 1. A 50 caliber M2 HB machine gun in front of the commander's hatch. On the M1 and M1A1, this gun is mounted on the commander's weapons station. This allows the weapon to be aimed and fired from within the tank. Normal combat loadout for the M1A1 is a single 100-round box of ammo at the weapon, and another 900 rounds carried. The later M1A2 variant had a flex mount that required the tank commander to expose his or her upper torso in order to fire the weapon. In urban environments in Iraq, this was found to be unsafe. With a common remote-operated weapons systems add-on kit, an M2A1 50 caliber machine gun, M240, or M249 SAW can be mounted on a Crow's remote weapon platform. Current variants of the tank urban survival kit on the M1A2 have forgone this, instead adding transparent gun shields to the commander's weapon station. The upgrade variant, called the M1 Abrams Integrated Management, equips the 50 caliber machine gun with a thermal sight for accurate night and other low visibility shooting. Number 2. A 7.62mm M240 machine gun in front of the loader's hatch on a skate mount. Some of these were fitted with gun shields during the Iraq War, as well as night vision scopes for low visibility engagements and firing. This gun can be moved to the tank commander's position if the M2 50 caliber is damaged. Number 3. A second 7.62mm M240 machine gun in a coaxial mount. In other words, it points at the same targets as the main gun, to the right of the main gun. The coaxial machine gun is aimed and fired with the same computerized firing control system used for the main gun. On earlier M1 and M1A1s, 3,000 rounds are carried, all linked together and ready to fire. This was reduced slightly in later models to make room for new systems electronics. A typical 7.62mm combat loadout is between 10,000 and 14,000 rounds carried on each tank. Optional. A second coaxial 50 caliber M2 HB machine gun can be mounted directly above the main gun on a remote weapons platform as part of the CSAM package. Aiming. The Abrams is equipped with a ballistic fire control computer that uses user and system supplied data from a variety of sources to compute, display, and incorporate the 3 components of a ballistic solution: lead angle, ammunition type, tube wear, propellant temperature, wind speed, air temperature, the relative motions of the target and the Abrams, and range to target, to accurately fire the main gun. These three components are determined using a laser rangefinder, crosswind sensor, and a pendulum static cant sensor, data concerning performance and flight characteristics of each specific type of round, tank-specific bore sight alignment data, ammunition temperature, air temperature, barometric pressure, a muzzle reference system that determines and compensates for barrel drop at the muzzle due to gravitational pull and barrel heating due to firing or sunlight, and target speed determined by tracking rate tachometers in the gunner's or commander's control handles. All of these factors are computed into a ballistic solution and updated 30 times per second. The updated solution is displayed in the gunner's or tank commander's field of view in the form of a reticle on both day and thermal modes. The ballistic computer manipulates the turret and a complex arrangement of mirrors so that all one has to do to keep the reticle on target and fire to achieve a hit. Proper lead and gun tube elevation are applied to the turret by the computer, greatly simplifying the job of the gunner. The fire control system on the M1 and M1A1 variants is the Computing Devices Canada Ballistic Computer System. On the M1A2, the fire control electronics unit is manufactured by GDLS. The laser designator is a Hughes model. The fire control system uses this data to compute a firing solution for the gunner. The ballistic solution generated ensures a hit percentage greater than 95% at nominal ranges. Either the commander or gunner can fire the main gun. Additionally, the commander's independent thermal viewer on the M1A2 can be used to locate targets and pass them on for the gunner to engage while the commander scans for new targets. If the primary sight system malfunctions or is damaged, the main and coaxial weapons can be manually aimed using a telescopic sight bore-sighted to the main gun known as the gunner's auxiliary sight. The GAS has two interchangeable reticles, one for heat and multi-purpose anti-tank ammunition, and one for APF SDS and smart target activated fire and forget ammunition. Turret traverse and main gun elevation can be performed with manual handles and cranks if the fire controller hydraulic systems fail. The commander's M2HB 50 caliber machine gun on the M1 and M1A1 is aimed by a 3x magnification sight incorporated into the commander's weapon station, while the M1A2 uses the machine gun's own iron sights or a remote aiming system such as the common remotely operated weapon station system when used as part of the tank urban survival kit. The loader's M240 machine gun is aimed either with the built-in iron sights or with a thermal scope mounted on the machine gun. In late 2017, the 400 USMC M1A1 Abrams were to be upgraded with better and longer range sights on the Abrams integrated display and targeting system, replacing the black and white camera view with a color sight and day-night thermal sight, simplifying handling with a single set of controls and a slew to Q button that repositions the turret with one command. Preliminary testing showed the upgrades reduced target engagement time from 6 seconds to 3 by allowing the commander and gunner to work more closely and collaborate better on target acquisition. Mobility. Tactical. The M1 Abrams powertrain consists of an AGT 1500 multi-fuel gas turbine, originally made by Lycoming, now Honeywell, capable of 1,500 shaft horsepower at 30,000 RPM and 395 pound-foot at 10,000 RPM, and a 6-speed Allison X1100 3B hydrokinetic automatic transmission. This gives it a governed top speed of 45 miles per hour on paved roads and 30 miles per hour cross-country. With the engine governor removed, speeds of around 60 miles per hour are possible on an improved surface. However, damage to the drivetrain and an increased risk of injuries to the crew can occur at speeds above 45 miles per hour. The tank was built around this engine and it's multi-fuel capable, including diesel, gasoline, marine diesel, and jet fuel, such as JP4 or JP8. And the AGT 1500 jet fuel has poorer fuel economy and operating range compared to diesel. By 1989, the Army was transitioning solely to JP8 for the M1 Abrams, part of the plan to reduce the service's logistics burden by using a single fuel for aviation and ground vehicles. The Australian M1A1 AIM SA burns diesel fuel since the use of JP8 is less common in the Australian Army. The gas turbine propulsion system has proven quite reliable in practice and combat, but its high fuel consumption is a serious logistic problem. It burns between 1.5 and 3 gallons per mile. The turbine is very quiet when compared to diesel engines of similar power output and produces a high-pitched whine, reducing the audible distance of the sound, thus earning the Abrams the nickname Whispering Death during its worldwide debut at the 1982 Reforger exercise. By the time production of the AGT 1500 ended in 1994, the U.S. had purchased 12,000 such engines. In 2006, the Army awarded Honeywell a contract to overhaul 1,000 engines, with the options for up to 3,000 more. The Army received proposals, including 2 diesel options, to provide the common engine for the XM 2001 Crusader and Abrams. In 2000, the Army selected the gas turbine engine LV-105 from Honeywell and subcontractor General Electric. The new LV-105 engine was smaller, with rapid acceleration, quieter running, and no visible exhaust. It also featured a 33% reduction in fuel consumption and near drop-in replacement. The common engine program was shelved when the Crusader program was canceled. Phase 2 of Army's Partnership for Reduced O&S Costs engine program, however, called for further development of the LV-105 in replacement of the current AGT 1500 engine. From 1991 to 1994, the Army fitted 1,500 Abrams turrets with external auxiliary power units. APUs allow the Abrams to run some functions without running on the engine. Some Abrams tanks that saw service during the Gulf War were fitted with such a device. Although the Army favored an Under Armour APU, Congress instead funded a short-term modification to 336 M1 Abrams. These were installed in 1997. An Under Armour APU located in the hull was chosen for the M1 SEP variant. When this proved unreliable, it was replaced with a battery-assisted alternate APU starting in 2005. Although the M1 tank is not designed to carry riders easily, provisions exist for the Abrams to transport troops and tank descent with turret stabilization device switched off. A battle-equipped infantry squad may ride on the rear of the tank behind the turret. The soldiers can use ropes and equipment straps to provide handholds and snap links to secure themselves. The Abrams T-156 is a permanently bonded rubber track pad, a distinctive feature not found on any other tank. Unlike other tanks with replaceable track pads on the Abrams, a worn track pad is remedied by replacing the entire track shoe. The Abrams non-removable track pads save weight but are less desirable in snow as the pads cannot be replaced with grousers. As of 2007, M1 Abrams track wear constitutes the second largest consumable expense in the U.S. Army, surpassed only by meals ready-to-eat consumption. In 1988, the Army awarded FMC Corporation a contract for T-158 tracks rated for 2,100 miles, or about double the life of the previous shoe. These feature replaceable pads and are about 3,000 pounds heavier. The driver is equipped with a thermal viewer. On at least some models, this is the Hughes AN VAS-3. Strategic mobility is the ability of the tanks of an armored force to arrive in a timely, cost-effective, and synchronized fashion. The Abrams can be carried by a C-5 Galaxy or a C-17 Globemaster III. The limited capacity caused serious logistical problems when deploying the tanks for the first Gulf War, though there was enough time for 1,848 tanks to be transported by ship. The Marines transported their Marine Air Ground Task Force Abrams tanks by combat ship. A Wasp-class landing helicopter dock typically carried a platoon of 4 to 5 tanks attached to the deployed Marine Expeditionary Unit, which were then amphibiously transported to shore by a landing craft air cushion at 1 combat-ready tank per landing craft. The Abrams is also transportable by truck, namely the Oshkosh M1070 and M1000 heavy equipment transporter system for the U.S. military. The HETS can operate on highways, secondary roads, and cross-country. It accommodates the 4 tank crew members. The Australian Army uses customized manned trucks to transport its Abrams. The first instance of the Abrams being airlifted directly into a battlefield occurred on October 1993. Following the Battle of Mogadishu, 18 M1 tanks were airlifted by C-5 aircraft to Somalia from Hunter Army Airfield, Georgia. Issues. Air filter clog. In a NSIA report on the Abrams in the Gulf War, crews reported issues related to the turbine engine. Other than the fuel consumption concerns, they noted the Abrams suffered from sand clogging the filters, which were known to cause reduced fuel economy or, in the worst case, engine damage. Doctrine, crew responsibilities, and platoon operations. Before the M1 Abrams program, the U.S. Army had designed tanks to conform to doctrine. This approach changed with the XM1, where the Army wrote its doctrine after developing the tank. The U.S. Army's Abrams tank doctrine was influenced by German, British, American, and Soviet ideas. The German concept of Auftragstaktik, or mission-type tactics, a military doctrine emphasizing decentralized decision-making, and Schwerpunkt, or main point, the massing of resources around a focal point, were influential. German-type breakthrough tactics favored by General George S. Patton, commander of the 7th Army in the Mediterranean theater of World War II, were advocated by Creighton Abrams and his devotees, U.S. Army Training and Doctrine Command, commanding Generals William E. Dupuy and his successor Don A. Starry. The Army's new fighting doctrine was drafted by Tradoc, commanding General Dupuy, and was heavily influenced by lessons from the 1973 Arab-Israeli Yom Kippur War. Field Manual 100-5 Operations, published in 1976, became one of the most controversial documents the Army had ever published, according to Orr Kelly. The document recognized that U.S. forces would quickly become outnumbered in the case of a surprise Soviet invasion. It called for U.S. forces to maneuver quickly to where they were needed to mount an active defense oriented towards blunting the spearhead of the attacking force. Critics of this document noted that Soviet attacks would come in waves that would overwhelm U.S. defenses. The revision to the manual, which faced criticism rivaling that of the first edition, was published in 1982. The manual's emphasis was influenced by Dupuy's successor, Starry. It called for using the entire depth of the battlefield to strike the enemy and to prevent him from concentrating his firepower or maneuvering his forces to a point of his choice. This alarmed NATO allies, who considered U.S. counterattacks across enemy borders to be needlessly provocative. The third revision of the manual, published in 1986, left open the possibility of attacking across enemy borders at the discretion of politicians. When the Abrams entered the U.S. Army service in 1980, its arrival marked an organizational change. The tank battalion went from 3 companies of 3 platoons to 4 companies of 3 platoons. The standard tank platoon fell from 5 tanks, a number consistent since the first days of the Tank Corps in World War I, to 4. The change reflected both the improved capability of the new tank but also its cost. The reduction in platoon size necessitated changes in tactics oriented upon platoon and section actions, in which the platoon leader had to both fight his tank and manage the unit. United States. Platoon organization within the U.S. Army and U.S. Marine Corps of 2019 is as follows. A tank platoon includes 4 Abrams MBTs organized into 2 sections with 2 tanks in each section. A section consists of the platoon leader, who is the commander of the vehicle designated as Tank 1, and the platoon leader's wingman, who is the commander of Tank 2. B section consists of the platoon sergeant, who is the tank commander of Tank 4, and Tank 3 is the platoon sergeant's wingman. The wingman concept requires that individual tanks orient off the tank to its left or right side. In the tank platoon, Tank 2 orients off the platoon leader's tank, while Tank 3 orients off the platoon sergeant's tank. The platoon sergeant orients off the platoon leader's tank. The tank platoon is organic to armor companies of a combined arms battalion. The platoon may be attached to a number of organizations, commonly a mechanized infantry company, to create company teams. It may also be placed under the control of an infantry organization. The exact amount of control the gaining unit would have is determined by the command relationship established by its higher headquarters. The armor company is organized, equipped, and trained to fight pure or as a task-organized company team. The armor company includes an HQ and 3 tank platoons. The company headquarters is equipped with 2 MBTs, armored personnel carriers, and wheeled vehicles for mission command, command and control sustainment. Maintenance and operation. A series of TM9 technical manuals cover various aspects of the tank's maintenance and operation. The exact number and titles of TM9 manuals for the M1 Abrams may vary depending on the specific variant and the date of publication. M1, initial production model with a 105mm rifled gun. M1A1, upgraded with a 120mm smoothbore gun, improved armor, and a bustle rack. M1A2 features a commander's independent thermal viewer, improved fire control systems, and an enhanced digital architecture. M1A2 SEP, or System Enhancement Package, a series of upgrades to the M1A2, including SEP V2 and V3 with further improvements. Hull. Engine and powertrain. Engine, type, its components and maintenance procedures. Transmission, system type, including gearboxes and differentials. 3. Air intake and filtration system, components and their function. Mobility systems. 1. Suspension, system type, including road wheels and bogies. 2. Tracks, type and replacement procedure. 3. Steering and braking system, type and their operation. Variants and upgrades. Over its multi-decade lifetime, the M1 has experienced many variants and upgrades. Before production, the primary three were the General Motors XM1 validation phase prototype, Chrysler XM1 validation phase prototype, XM1 FSCD Chrysler pre-production test model. 11 full-scale engineering development test bed vehicles were produced in 1977 to 78. These vehicles were also called pilot vehicles and numbered PV1 through PV11. M1. First production variant, 2,374 produced from 1979 to 1985. The first 110 tanks were low-rate initial production models and were still called XM1s. The first rollout ceremony was held on 28 February 1980, and the tank was officially named the M1 Abrams. The M1 variant was retired from active U.S. Army service in 1996. Variants. K1. Republic of Korea Indigenous Tank, an M1 derivative customized for the Republic of Korea Armed Forces. Emphasis on compact, low-silhouette design. M1 Abrams Block 3 tank test bed. Prototype built in 1983 as part of TACOM's Abrams Block 3 program, whose purview was to eventually create the M1A3, featuring an unmanned turret with a .44 caliber, 120mm M256 smoothbore gun, 3 crew members sitting side by side inside an armored capsule at the front of the hull, and a suite of cameras and thermal viewers to preserve the crew's situational awareness. The main armament was linked to a Megget mechanical autoloader and a 44-round vertical ammunition carousel inside the turret basket. This system could provide a sustained rate of fire of 10 rounds per minute and successfully completed over 40,000 round loading-unloading cycles without malfunctioning during testing. Due to the absence of a full-fledged manned turret and the lack of internal armor packages, the vehicle only weighed 45 tons. The program was canceled after the end of the Cold War, and its only prototype is now on display at the U.S. Army Armor and Cavalry Collection at Fort Moore, Georgia. IPM-1. Improved performance or improved protection. 894 were produced from 1984 to 1986. It contained upgrades and reconfigurations like a rear storage bustle rack, improved armor, suspension, transmission, and final drives. M1A1. A total of 4,753 were built from the Army from 1985 to 1993 and 221 for the Marines from 1989 to 1991. It had a pressurized NBC system, rear bustle rack for improved storage of supplies and crew belongings, redesigned blow-off panels, and M256 120mm smoothbore cannon. Egypt purchased M1A1 kits for local assembly beginning in 1990. M1A1HA heavy armor added first-generation depleted uranium armor components. Some tanks were later upgraded with second-generation depleted uranium armor components and are unofficially designated M1A1HA+. M1A1HC are heavy common. Added new second-generation depleted uranium armor components, digital engine control, and other small upgrades common between Army and Marine Corps tanks. M1A1D Digital, a digital upgrade for the M1A1HC to keep up with the M1A2 SEP manufactured in quantity for only 2 battalions. M1A1 AIM V1 Abrams Integrated Management, a program whereby older units are reconditioned to initial factory standards, and the tank is improved by adding forward-looking infrared and far target locate sensors, a tank infantry phone, communications gear, including FBCB2 and Blue Force tracking to aid in crew situational awareness, and a thermal sight for the 50 caliber machine gun. 59 M1A1 AIMs sold to Australia, 49 of which were later donated to Ukraine. M1A1 AIM V2, M1A1 SA are situational awareness. Upgrades similar to AIM V1 tanks and new third-generation depleted uranium armor components. Configuration for the Royal Moroccan Army, which is almost identical to the Australian variant, except exportable turret armor is installed by General Dynamics Land Systems to replace the depleted uranium armor. M1A1 SA UKR, official designation for M1A1 SA variants given to Ukraine via Foreign Military Sales Program. M1A1 FEP, Firepower Enhancement Package, similar upgrade to the AIM V2 for USMC tanks. M1A1 KVT, Krasnovian variant tank. M1A1s that have been visually modified to resemble Soviet-made tanks for use at the National Training Center fitted with Miles gear and Hoffman device. M1A1M, an export variant ordered by the Iraqi Army. M1A1 AIDATS upgrade. Upgrade-only variant to all USMC General Dynamics M1A1 Abrams tanks to improve the tank commander's situational awareness with an upgraded thermal sight, colored day camera, and stationary color display. M1 Thumper, also known as ATAC System Demonstrator, was a single M1A1 fitted with a heavily modified unarmored M1A1 turret to trial the experimental XM291 ATAC smoothbore gun, a more powerful replacement for the M256, capable of firing either single-piece 120mm or two-piece 140mm ammunition with only a barrel change. The 140mm rounds were too large and heavy to be moved around by a human loader, mandating the installation of an XM91 mechanical cassette autoloader. The Thumper underwent testing in 1988 and in the 1990s at Aberdeen Proving Ground, where it demonstrated accuracy equal to an M1A1's, but with significantly higher armor penetration capability. Component Advanced Technology Testbed was a pair of highly modified prototypes conceived under the auspices of the Advanced Tank Armament System program to test several promising technologies. Two vehicles were built in 1993 and 94. The first one, dubbed Phase 1, paired a spare M1 hull with a modified turret fitted with a 48 caliber 140mm Watervillette Arsenal XM291 smoothbore cannon and a Benet Labs XM91 mechanical autoloader inside the bustle. The second vehicle, codenamed Phase 2, used the same turret as basis, but mated it to a brand new M1 hull altered to contain a more compact Cummins XAP 1000 AIPS diesel engine and two vertically stacked horizontal carousels between the turret basket and the power pack compartment. Phase 2 also trialed new single-shoe XT166 tracks, an in-arm hydropneumatic suspension, and the multi-sensor target acquisition system with its low-power millimetric wave radar. Both vehicles were tested extensively at Aberdeen Proving Ground. The aforementioned Thumper is often erroneously described as a detuned CATTB, although it predates the latter by 5 years. M1A2. M1A2 came in many variants and were produced for multiple countries beyond the US. The M1A2 offers the tank commander an independent thermal sight and ability to, in rapid sequence, shoot at two targets without the need to acquire each one sequentially. Also, second-generation depleted uranium armor components. Baseline: 62 vehicles produced from 1991 to 92. Initial operating capability in 1993. The U.S. upgraded 206 M1A1s to M1A2 from 1993 to 1996 as Phase 1 and produced 315 for Saudi Arabia and 218 for Kuwait. The U.S. upgraded 800 to 900 units to M1A2 as Phase 2 from 1997 to 2001, some in the M1A2 SEP configuration. M1A2 SEP, or System Enhancement Package, fitted with new second-generation gunner's thermal sights, upgraded third-generation depleted uranium armor components with graphite coating. M1A2S, Saudi Arabian Package, Saudi Arabian variant upgrade based on M1A2 SEP with some features such as depleted uranium armor believed to be replaced by special armor. M1A2 SEP V2 added common remotely operated weapon station low profile as standard, colored displays, improved interfaces, a new operating system, improved crew compartment cooling, and new second generation thermal optics. M1A2 SEP V3, formerly the M1A2C, increased power generation and distribution, better communications and networking, new vehicle health management system, and line replaceable modules for improved maintenance, an ammunition data link to use airburst rounds, improved counter IED armor package, next generation armor package, and an auxiliary power unit under armor to run electronics while stationary instead of the engine, visually distinguishing the version by a small exhaust at the left rear. Lethality enhancements include the M829A4 kinetic energy anti-tank round to target advanced explosive reactive armor and active protection systems. The M1147 AMP round combines multiple functionalities including point detonate, delay, and airburst modes, replacing 4 older round types and providing capabilities for obstacle reduction, bunker defeat, and precision airburst against anti-tank missile teams. The ammunition data link enables the round to communicate with the fire control system, allowing the crew to program the desired mode in real time for maximum effectiveness. The SEP-V3 also has improved forward-looking infrared technology, which significantly improves target acquisition, identification, and engagement under all conditions, including obscurance such as fog and smoke. The IFLIR integrates long-wave and mid-wave infrared sensors into both gunner's primary sight and the commander's independent thermal viewer, offering enhanced detection capabilities at greater ranges. It provides 4 fields of view displayed on high-definition screens, enabling faster and more accurate engagement of targets compared to older second-generation FLIR systems. The low-profile CROWS significantly reduces the weapon station's profile, enhancing the tank commander's situational awareness with upgraded day cameras featuring picture-in-picture technology, a 340% larger field of view in its wide FOV mode, and improved targeting capabilities under both open and closed hatch conditions. More passive ballistic protection for turret faces along with new explosive reaction armor mountings, and trophy active protection system for turret sides. Prototypes began testing in 2015. Production, maximum of 31 M1A2 SCP-V3 a month with standard rate of 12 per month, and 1 standard shift and an actual annual rate of 109. M1A2T, special configuration reportedly offered for sale to Taiwan as of March 2019. Per DSCA statement, it is roughly equivalent to the M1A2 SCP-V3, except depleted uranium armor is replaced by FMS export armor. Trophy APS system not mentioned. M1A2R variant for the Romanian Army, configuration of the M1A2 SCP-V3. M1A2K variant for the Kuwaiti Army, slated to replace Kuwait's existing M1A2 fleet. M1A2 SCP-V4 is the commander's primary sight, also known as the commander's independent thermal viewer, and gunner's primary sight, upgraded with 3rd Gen FLIR, an improved laser rangefinder, color cameras, advanced meteorological sensors, laser warning detection receivers, directional smoke grenade launchers, and an integration of the XM1147 120mm tank round. The ANVVR-4 laser warning receiver and ROSI rapid obscurant system were trialed by the U.S. Army for the M1A2 and Bradley fighting vehicle. Abrams X is a technology demonstrator of the M1 Abrams series by General Dynamics Land Systems. The Abrams X features a lightweight waterlet Arsenal XM360 smoothbore gun with pepper pot muzzle brake, an autoloader which reduces the crew to 3, an unmanned turret, a hybrid diesel-electric Cummins ACE power pack that gives 50% more fuel efficiency, a 30mm XM914 chain gun in a remote weapon station, trophy active protection system with 3 launchers, an augmented reality suite that would increase the crew's situational awareness thanks to cameras and sensors mounted around the tank's exterior, a silent mode when running on electric power, the ability to be updated more easily than existing tanks, and use loitering munitions such as the AeroVironment Switchblade, as well as surveillance drones, and reduced weight for improved mobility. In October 2022, GDLS released a video showing the technology demonstrator and various technology tests. M1E3 includes modular open systems architecture with a 20-ton weight reduction to 60 tons. The Army Science Board reported an independent assessment of the 2040 battlefield and its implications for the 5th-generation combat vehicle, which reportedly led Army leadership to establish the program, recommended a $2.9 billion 7 to 8 year long program to develop a 5th-generation combat vehicle with proposed capabilities including the plan was to field first units in 2026 to 2027, 1 pre-prototype delivered in mid-December 2025. So, proposed capabilities are a 3-person crew with an unmanned turret, hybrid electric drive with Caterpillar engine and SAPA transmission for greater fuel efficiency, autoloader and new main gun, AI threat ranking and targeting and fire control, gun-launched maneuvering hypersonic and guided missiles, integrated active protection system, improved command, control, and networking capabilities, artificial intelligence applications, ability to network with drones and robotic vehicles, and masking capabilities to reduce the vehicle's thermal and electromagnetic signatures. Specialized Surrogate Research Vehicle. The Surrogate Research Vehicle project was conducted from 1980 to 1987 to evaluate the effectiveness of different crew arrangements using a turretless Abrams testbed. These modifications included adding 2 crew stations to the front hull. 2 crew positions were retained in a rotating basket where the turret had been. Armored Recovery Vehicle. Initially known as the RV-90, this was a prototype designed by General Dynamics. It was produced under contract with TACOM in 1988, despite an earlier preliminary decision to procure the M88A1E1. The prototype was evaluated against the M88A1E1 later that year. The Abrams RV was based on the Abrams chassis but housed a crew of 3 in a unique armored superstructure. The Army selected the M88A1E1 regardless, which went into production as the M88A2 Hercules. Air-Ground Defense System. Proposed air defense variant of the Abrams equipped with dual 35mm Bushmaster 3 autocannons, 12 ADATS missiles, and advanced electro-optical and radar targeting systems derived from the ADATS. It was supposed to be capable of both air defense and anti-tank purposes with the ADATS MIM-146 missiles, which was a dual-purpose ATGM SAM. The proposal never saw consideration and was never developed further. M1 Panther II. A mine-clearing vehicle with turret removed, mine rollers on the front, and a magnetized dog bone. This could be operated remotely or with a crew of 2. 6 were built, and 2 were deployed in 2007 by the USMC in Iraq. M104 Wolverine Heavy Assault Bridge. GDLS produced these under contract for the U.S. Army with testing beginning in 1996. The 26-meter bridge was produced by Krauss Maffei Wegmann. The chassis is an Abrams converted to M1A2 standard. 43 units were produced when production wrapped up in 2003. Battle Command Vehicle. The vehicle was visually modified with a mock M256 gun to appear like an ordinary Abrams MBT, but featured communications equipment and workstations for battle commanders. United Defense LP constructed a prototype, which the Army tested at Fort Hood in 1997. Visually modified. The National Training Center possesses 28 visually modified M1A1s resembling T-80s. M1 Grizzly. In 1997, TACOM awarded United Defense a $129 million contract to construct this vehicle based on the Abrams chassis. This was capable of clearing minefields and demolishing obstacles with its dozer blade and telescopic power-driven arm. The chassis had a suspension of M1A2 standard and was operated by a crew of 2. 2 vehicles were delivered to the Army in 1999. Development was halted by the following year. M1074 Joint Assault Bridge. Bridge layer combining a heavy scissor bridge with the M1 Abrams chassis. Expected to reach low-rate initial production in 2019 to replace the M60 AVLB and M104 Wolverine. M1150 Assault Breacher Vehicle. Assault variant for the USMC. Based upon the M1A1 Abrams chassis, the Assault Breacher Vehicle has a variety of systems installed, such as a full-width mine plow, 2 linear demolitions charges, and a lane marking system. Reactive armor has been fitted to the vehicle, providing additional protection against heat warhead-based weapons. The turret has been replaced by a new, smaller one with 2 MIC-LIC launchers at its rear. An M2 HB 50 caliber machine gun in a remote weapon station is mounted on the commander's cupola, and a bank of grenade launchers are fitted to each side of the superstructure to cover the frontal arc for self-protection. Additional equipment. Mine clearing plows. An early example consists of 2 mine plows and a chain with a weight running between them. The mine clearing blade system. It is capable of clearing mines up to 6 feet in front of the tank's path. Mine clearing rollers. The tank-mounted mine clearing roller comprises 2 roller banks of 5 discs each and a chain with a weight running between the rollers. Self-protection combat roller targets pressure-activated explosive devices. The system comprises 2 4-wheel roller gangs. An optical magnetic system duplicator can be fitted to help protect the equipment from the effect of magnetic influence fused mines. Surface clearance device. The SCD is employed to clear surface-laid mines and IEDs from roads, trails, and rough terrain. There are 2 versions of the SCD, a V-blade optimized for clearing routes and a straight-angle blade which is optimized for clearing staging and assembly areas. Vehicle magnetic signature duplicator. The VEMSID causes detonation of magnetic influence mines. The system comprises 4 emitter coils, 2 associated power boxes, and an MSD control unit. Bulldozer attachment. The U.S. Army tested this attachment in 1982. This was unsuccessful in part because it resulted in transmission overheating and was never used. All right, we then have the Abrams specifications. I'm going to skip reading this chart. You can find it. The article is going to be linked in the description, so you can go check that out if you wish. Operators. Current operators. Australia, Australian Army. 59 M1A1 as of 2024. AIM configuration tanks. They were bought from the US in 2006 and replaced the Leopard AS1 in 2007. As of 2017, the Australian government was considering expanding the Army's fleet of Abrams to 90 tanks. In April 2021, the U.S. granted an FMS for 160 M1A1 tank hulls to produce 75 M1A2 SEPV3 tanks, 29 M1150 assault breacher vehicles, and 18 M1074 joint assault bridges, including the development of a unique armor package for the Australian Army. In January 2022, Australia committed to purchase 120 tanks and armored vehicles, including 75 M1A2s, at a total cost of $3.5 billion and to be delivered in 2024. The M1A2s will replace their 59 M1A1s. On 17 October 2024, the Australian government announced that it will be gifting 49 of its retired M1A1 tanks to Ukraine. This donation was completed in December of 2025. 14 M1A2s are scheduled to enter service by the end of 2024. Egypt, Egyptian Army. 1,130 M1A1 as of 2024. 1,360 M1A1 tanks assembled in Egypt for the Egyptian Army in cooperation with the United States. Iraq, Iraqi Army. 100 M1A1 as of 2024. Iraq purchased 120 M1A1SA from the U.S. in 2008. The first 11 tanks were delivered to the Iraqi Army in August 2010, with all deliveries completed by August 2011. In October 2012, it was reported that 6 more tanks were being delivered. 4 battalions of the 9th Armored Division were equipped with M1s by 2014. 1st and 2nd of the 34th Brigade and 4th and 5th of the 35th Brigade. Iraq purchased 175 more M1A1 in 2014, though it is unclear if these were delivered. Kuwait, Kuwaiti Army. 218 M1A2K as of 2024. 218 M1A2s produced around 1995. Kuwait took delivery of its first 217 M1A2K variants in 2021. Morocco, Royal Moroccan Army. 221 M1A1SA as of 2024. 222 M1A1SA situational awareness tanks ordered in 2015. Deliveries under the contract started in July 2016 with an estimated completion date of February 2018. The contract includes 150 refurbished and upgraded tanks to the special armor configuration. Morocco took delivery of the first batch of M1A1SAs on 28 July 2016. A foreign military sale for 162 M1A2Ms was approved by the U.S. Department of State in November 2018 and sent to Congress for final approval. In October 2020, General Dynamics Land Systems was awarded a $11.9 million contract to upgrade 162 Abrams tanks to the M1A2 SEPV3 configuration. This contract was completed in March 2022. Poland, Polish Land Forces. Poland purchased 116 former U.S. Marine Corps M1A1s in January 2023. The first 14 arrived on 28 June 2023. A further 26 were delivered in November 2023. On 8 January 2024, the next 29 were delivered. Deliveries were completed in June 2024. Poland also purchased 250 M1A2 SEPV3 tanks. Production is set to finish by 2024 and delivery in early 2025. 28 M1A2 SEPV2 tanks were released in July 2022 to train crews until deliveries begin. Saudi Arabia, Saudi Arabian Army. 575 M1A2S as of 2024. 373 Abrams tanks, first ordered to be upgraded to M1A2S configuration in Saudi Arabia. 69 more M1A2S tanks ordered on 8 January 2013 to be delivered 31 July 2014. South Korea, Republic of Korea Army and Marine Corps, operates K1 series, a customized M1 Abrams since 1987. Taiwan, Republic of China Army. In July 2018, Taiwan's Ministry of National Defense budgeted money to buy 108 M1A2Ts from the United States to replace its aging CM-11 Brave Tiger and M60A3 TTS tanks. The United States Department of State approved the $2.2 billion sale in July 2019. A sale of 108 M1A2Ts was later finalized. The first 2 were delivered to Taiwan in June 2022, with an additional 38 delivered in December 2024. Ukraine, Ukrainian Ground Forces. 31 M1A1SA situational awareness. 31 M1A1 Abrams were delivered prior to 16 October 2023 as part of the U.S. support for Ukraine. As of 21 March 2023, the U.S. government is offering to supply Ukraine with older M1A1 Abrams tanks that have been upgraded very similar capability to the M1A2, as opposed to the newer M1A2 tanks in an effort to speed up delivery. According to Pentagon Press Secretary, U.S. Air Force Brigadier General Pat Ryder, these tanks are to be delivered by fall 2023 instead of the original delivery time of mid-2024. These tanks are to be taken from existing M1A1 excessive hulls from United States stocks and modernized to the required standard. In April, the United States announced that the Abrams tanks will soon be sent to Germany so that Ukrainian soldiers can start training on them. On 6 September, the U.S. said it would supply Ukraine with depleted uranium ammunition for Abrams tanks, despite initially refusing to do so. On 25 September, it was reported that Ukraine had received its first shipment of M1 tanks. On 16 October 2024, the Australian government announced a $245 million Australian dollar aid package for Ukraine. It included the transfer of 49 M1A1 Abrams tanks to Ukraine, which was completed in December 2025. As of 1 July 2025, according to the Orikspionenkop website, 10 M1A1SA Abrams tanks have been confirmed destroyed by the Russian forces, 1 damaged, 10 abandoned, and 1 captured, meaning that Ukrainians have lost 22 M1A1SA Abrams, while Kiev Independent claims all but 4 of the 31 delivered from the U.S. were destroyed. United States. United States Army received over 8,100 M1, M1A1, and M1A2 tanks combined. U.S. Army, 2,640 total in service, 540 M1A1 SA, 1,410 M1A2 SEPV2, 690 M1A2 SEPV3s, 1 pre-prototype M1E3 for testing, estimated as of January 2025. Future operators. Bahrain, Royal Bahrainian Army. On 19 March 2024, the U.S. Defense Security Cooperation Agency announced that the Department of State had approved the possible foreign military sale to Bahrain of 50 M1A2 SEPV3 Abrams main battle tanks. Romania, Romanian Land Forces. On 7 March 2023, a senior defense official announced that Romanian Land Forces is in the process of advancing a proposal for the purchase of an Abrams tank battalion. In May 2023, the decision to buy 54 used M1A2 Abrams from United States Army stocks was approved by the Parliament of Romania. The Romanian M1A2 variant is designated M1A2R. On 9 November 2023, the U.S. Defense Security Cooperation Agency announced that the Department of State had approved the possible foreign military sale to Romania for 54 M1A2 tanks and related equipment for an estimated cost of $2.53 billion. Former operators. United States. United States Marine Corps. In 2020, the Marine Corps announced the disbandment of its tank units, citing a pivot towards amphibious warfare by implementing Force Design 2030. All 450 of the Marine Corps M1 Abrams MBTs were transferred to the U.S. Army with withdrawal from Marine Corps service being completed in May 2021. Former non-state operators. Islamic State. 9 vehicles were destroyed by ISIL in Ramadi. Kataib Hezbollah. 1 vehicle was seen in use by Kataib Hezbollah around January 2015. Another vehicle was again seen in use in January 2016, and another one was seen being transported in March 2016. Popular Mobilization Forces. 1 vehicle was seen in a PMF video montage. Examples on display. M1 at the Ronald Reagan Presidential Library and Museum in Simi Valley, California. M1A1 at the American Heritage Museum in Hudson, Massachusetts. M1 at the 1st Division Museum in Cantigny, Illinois. All right, that is, we reached the end. I was honestly wondering if that was going to happen, but that is massive. And for a child of the 80s, the M1 is it's just an iconic tank, and I thought it would be fun to look at. So I hope you enjoyed that. If you did, obviously give a like, subscribe if you're new here and you're enjoying this kind of content. But of course, the one thing I would really ask of you is that you drop some sort of a comment down below. Let me know about something that you'd like to hear about next, and we'll get that into the schedule. But regardless, thanks for watching, and we'll talk to you next time.